Hello, fellow developers! Today, we're going to talk about the Federated Credential Management API, or FedCM for short. FedCM is a browser-mediated way to handle federated identity. And identity federation is a way to delegate user authentication to an identity provider. For the users, it means they access multiple applications using just a single set of credentials. Think of a Sign In With button on a website. Whenever a user signs into a site using an account from another site, that's an example of a federated identity flow. FedCM is a proposed browser API that can improve identity federation flow for the users. It is designed to provide a more convenient and more private identity federation flow. Let's dive in and see how. At its core, FedCM is a web API. It allows users to log into websites called reliant parties using an account from another website, an identity provider. The FedCM API is protocol agnostic, and it operates on a different layer from standards like OAuth or SAML. The key innovation of FedCM is that it puts the browser in the middle. The browser serves as a trusted mediator between the user, the reliant party, and the identity provider. This means that before the user data is shared between the parties, the browser steps in and asks for user permission. This gives the user more transparency and control over their data in comparison to using other primitives like iframes or third-party cookies. Let's say healthprovider.example is an identity provider who implements FedCM. A website, pharmacy.example, allows users to sign in with their accounts from health provider. Let's see how the FedCM flow looks for a user signing on pharmacy.example. The user experience will slightly vary depending on the UX mode. As of Chrome 147, there are two UX modes in FedCM, active and passive. Independent of the mode, FedCM flow works without redirects so that users can stay in the context of the same page while signing in. Active mode requires a user gesture for FedCM dialog to appear, like clicking a Sign In With button. After the user interaction, the FedCM dialog will appear even if the user is not signed in to the identity provider. Let's have a look at an example. Say the user visits pharmacy.example that uses healthprovider.example as their identity provider. The user is signed into their health provider account. In this case, when the user clicks the Sign In button, the browser displays a FedCM dialog. The dialog prompts the user to sign in to the pharmacy site with the health provider account and states which data health provider will share. If the user chooses to continue, this account information will be shared with pharmacy.example. Note that there is no top-level redirect or pop-up windows. The login journey happens in the same page context. But what if the user doesn't have an active session with healthprovider.example? Because the user is currently not signed in, a pop-up window will appear. This pop-up is the login endpoint specified by healthprovider.example. The health provider pop-up window is configured to close automatically after the user signs in. When the pop-up closes, the user is focused on the pharmacy site again, with the FedCM dialog displayed. Passive mode does not require a user gesture for the FedCM dialog to fire. However, the user has to be signed in to the identity provider for the streamlined login experience. Say the user is signed in with healthprovider.example. When the user visits pharmacy.example, if FedCM API is called, the browser displays a FedCM dialog. Depending on whether the user already has an account on pharmacy site, the dialog will prompt the user to either sign up or sign in. We are currently exploring other UI options. Do you have ideas or feedback? Click the link and share them. FedCM offers benefits for everyone involved in the authentication process: users, reliant parties, and identity providers. For users, FedCM in passive mode offers a seamless one-tap sign-in flow that is consistent and recognized by the users across websites. Active mode eliminates the need for redirects and allows the user to stay in the same context throughout the sign-in journey. It's also resilient to future bounce tracking mitigations. FedCM is a better solution for privacy than conventional identity federation solutions. First, the information is only exchanged between the relying party and the identity provider after the user explicitly chooses to sign in with the identity provider on the relying party. Additionally, the FedCM team is experimenting with the so-called delegation model that significantly enhances the privacy property of this API. The identity providers who choose to use the delegation model will not be able to know on which relying party the user is signing in. And this is obviously better for user privacy. And finally, the FedCM UI helps the users better understand what data is being shared. Relying parties can support a wider selection of identity providers without cluttering their UI with dozens of login buttons. FedCM helps the browser to dynamically show only the accounts that are actually relevant to the user. This means no more static lists of identity providers. And because FedCM makes it easier for the user, relying parties also report higher sign-in rates with FedCM experience compared to conventional federated identity flow. And of course, FedCM works even without third-party cookies. This means that with FedCM Flow, relying parties can provide more users with personalized experience on their site. And finally, the identity provider. FedCM Flow works even when third-party cookies are not available, which means support for more users, for example, those who disabled third-party cookies in the browser. FedCM also does not rely on link decorations, which means that it is resilient to any bounce tracking mitigations. It's a win-win-win situation. So, what does it take to implement this? To enable FedCM, the identity provider needs to create and serve specific endpoints. The actual FedCM API call happens on the relying party side, the website the user is visiting. We strongly encourage identity providers to distribute an SDK. By having relying parties embed this SDK, the identity provider ensures that all the future updates to the implementation can be managed centrally by the identity provider without breaking the flow on the relying party's side. In short, to support FedCM, the identity provider needs to serve a well-known file and a set of specific endpoints. The well-known file acts as a map telling the browser where to find the configuration file and the required endpoints. The identity provider also needs to implement the following endpoints: an accounts endpoint to list the user's available accounts, an ID assertion endpoint which verifies the user and issues a secure token to log them in, a login endpoint which handles the sign-in page if the user isn't currently authenticated with the identity provider, and a client metadata endpoint to provide branding elements like relying party's logo or privacy policy to the browser's UI. This is just a high-level summary. To dive deeper into technical details and see the code, click the link in the description. And that's a quick overview of FedCM. If you want to learn more and get started with an implementation, visit go.gle/FedCM. The FedCM team is also working on other exciting updates to the API. Check out the link to our roadmap in the description to learn what's coming. And now, happy coding!